Hello, my name is Aneta, and this is Chemistry at Glance. Here I come with the next organic equations movie, and it's elimination reaction now. So we went through the nucleophilic reaction, we went nucleophilic substitution, we went through electrophilic addition. The next movie is elimination reaction. In elimination reaction, we also use NaOH, just like in our nucleophilic substitution. What we use from this NaOH is our OH minus ion. That's what we need. But you're probably asking, how do you know when it's an elimination reaction, when it's a nucleophilic substitution reaction, if we use OH minus for both of them? Well, you know this because in our elimination reaction, OH minus has to be dissolved in ethanol. It has to be dissolved in an alcohol. If it's dissolved in an alcohol, that means you're going to get an elimination reaction. If it wasn't dissolved in an alcohol, that would be a nucleophilic substitution. So again, we get a halogenoalkane. Let's use Br this time. We have our NaOH. There's not really a mechanism you need to know for this equation, so you just need to know the equation and what happens in it. So you need to know that you use NaOH, but what actually goes into the halogenoalkane is what actually reacts with the halogenoalkane is the OH minus ion. So elimination means that we are trying to eliminate this bromine from the equation. So what goes with it? We also have to eliminate one more hydrogen to make a double bond and HBr. This is the overall equation. So as you can see, although I'm putting NaOH, we're not actually getting NaOH on this side, because we're only using the OH. Of course, that has to be dissolved in ethanol. So what the elimination reaction does is takes halogenoalkanes and makes alkenes without the halogen. So we're removing the halogen, and we're also removing one more H with the halogen to form a carbon-carbon double bond. So elimination reaction is removing something to make a double bond. If you don't like that there's an Na here, what I usually do is put a long arrow going from this reactant to a product and then put NaOH in ethanol as the reagents. And then here we write the overall equation. This is not really the overall equation because we're not getting the Na out. So that's why I change it into a really long arrow and NaOH, being our reagent. The overall equation will look like this. Our halogenoalkane reacting with NaOH, we make our ethene. We also make hydrogen bromide, and we also make, we're not making hydrogen bromide, we're making water plus NaBr. And how do you know this equation will look like this? It's very different from this one, because as you can see, we make hydrogen bromide in this one, and we don't make it in the overall equation. This is because it only shows us the ions. We're not actually using the Na in this example, we're only using the OH minus ions. So the OH minus grabs, we actually, as you can see, there's no OH in either of them. It's just a halogen alkene, plus what's left from this to this. This is a reagent. It's not actually present in the equation. We just know it's needed for this equation to happen. In this overall equation, we're actually considering the NaOH as being a part of the reaction. We react these together, we form an alkene. We know this. We form NaBr, Na plus Br, and OH with one of the other H's. That's how our overall equation should look. This one is just that our halogen alkane reacts with this to form an alkene and whatever is left. This shows us what bonds with what in the solution. I hope this is not too complicated. I know it can be at first sight, but I hope you it's kind of clicking. The reagents and conditions you have to have is the NaOH, of course, in the ethanol. We need 78 degrees Celsius, and we also need reflux. So once more, one last time, just to make sure, halogen alkane to form an alkene and whatever is left. Reagent for this is NaOH dissolved in ethanol. Our overall equation shows us everything there is. If you look at the solution, in the solution we already have halogen alkane, we add sodium hydroxide, we form our alkene. There's also some water formed and NaBr formed. It's not so easy to explain everything, especially that I'm not a professional teacher. I'm just a student who tries to help out some other people who are struggling. I hope you liked the video, and if you did, leave a thumbs up. Subscribe to my channel for more videos, and see you soon. Bye.